over to Michael Kauffmann, and we will get to hear what he has to share with us about the Miracle Mile. Thanks so much, Michael.
Thanks, Renee. So when she was giving her a little intro, I was able to scroll through and see some of the people that are on. Joe, shout out in Portland, good to see you from a distance, and Matt down in Santa Barbara, and then Kyochi in Japan. So I'm really excited to be going global tonight in some ways. So anyway, welcome. I have a pretty fun presentation, something that has evolved over 5 years. I was telling Renee before we started that I had cooked this presentation up for an HSU class about 5 years ago. I thought, oh yeah, piece of cake, I can do that. And then I started to dive in and realized, man, I got a lot more information thanks to a bunch of people like Melissa DeServo and Eric Jules and some other folks that have been doing some research out in the Miracle Mile. So anyway, brand new presentation here, and I'm really excited about it. So let's dive in. Cool. So here we go. So except I opened the wrong presentation. Let's do, let's make a quick change here. That was my one I did a few weeks ago. Here it is. I hear everybody laughing at me out there right now. All right. So the Miracle Mile, we're going to go into the heart of the Russian wilderness, and I'm going to tell you some stories about how this place came to be in a lot of different ways, both deep time and more recent time. But I want to take a step back real quick, and I know some of you have seen this part of my presentation before, but is my video showing, Renee, or is it just you?
Your video is showing you. We don't see your presentation yet.
But you don't see my presentation. Oh my.
Yeah.
This is. Sorry, everybody. I think I got mixed up in my platforms here. Oh. Oy vey. Okay.
There we go.
Okay, cool. I was also saying that there's a little bit of a lag because we're on satellite internet, so I'll keep it kind of slow as far as transitions go. Okay, so here we're going to dive in. I want to tell you just a little bit about myself. I'm an educator in Humboldt County. I work with the school district. I work with the Humboldt County Office of Ed, and I also work with Save the Redwoods League. That's me teaching photosynthesis a few years ago. I'm an author. I've written 3 books, and I have a 4th on the way. I'm very excited about my 4th, but this one was one that when I first discovered the Miracle Mile, I wrote about it in Conifer Country. I didn't write about a lot of hidden places in the wilderness, but I felt like the Miracle Mile was one that was important to include, and I'm going to expand on that a little bit today. Conifers of the Pacific Slope, Field Guide to Manzanitas. I'll tell you a little bit more about that book at the end of tonight. And I'm also an ecologist. Currently, I'm working with a team at Humboldt State on a National Science Foundation grant on looking at drought response with conifers, but I've also worked extensively with the CNPS vegetation team. My last presentation a couple of weeks ago on Zoom was about these 2 research projects, Pacific Silver Fir and Yellow Cedar, and those are on the North Coast CNPS page. And then Whitebark Pine and Big Cone Douglas Fir work as well. I do have some of this information on my blog, and if you, I also put some information that will support tonight's presentation on my blog as well, michaelkauffmann.net/blog. So you can visit that later to find some of these resources I'm going to share. Okay, why am I crazy about conifers? I think they're a manageable means to understand biodiversity. They're harbingers for climatic change across millions of years. And they're gorgeous. This is one of my favorite Jeffrey pines on the planet, deep in the Siskiyou wilderness. And there's many, many conifers across the basically Western United States that I've fallen in love with just because of their charisma. So what is a conifer? Well, let's take a step back. On 425 million years ago or so, plants became compatible with land. The first of those were things like horsetails and club mosses and ferns, and they developed vascular tissue, which means they could grow up, and they reproduced with spores. Gymnosperms followed about 365 million years ago, and this includes the conifers. And those were followed by the angiosperms about 140 million years ago. So these are the seed plants. The gymnosperms and the angiosperms are the seed plants, and this was a big deal, a big leap from the spore. This promoted a dormancy and was a new pathway for distribution and evolution across the planet. And the gymnosperm seeds, they form on a variety of structures like a cone, but they remain naked. So this is different than the angiosperms seeds, which are enclosed. So I'm not going to get into details there, but that's why these are the two basically different groups of seeded plants. A little bit more about conifers. In the age of the dinosaurs, before the big asteroid hit, this was the heyday. There were about 20,000 species of conifers on the planet, probably more. It's all based on fossil record. And then about 65 million years ago, the adaptive radiation of angiosperms began. So the big asteroid hit, the world changed. There was a giant shift. And today there's about 1,000 species of gymnosperms and about 300,000 plus species of angiosperms. And this decline of gymnosperms and expansion of the angiosperms is one of the most important processes today in the history of plant life on Earth. Now, the news isn't all bad for the conifers, though. And I'll tell you why in a minute. But these are the 4 extant divisions of gymnosperms. We have cycads. These are mostly tropical. Metaphytes, things like the ephedras in the California desert. There's about 70 species worldwide. The ginkgos, there's 1 extant species. And then the conifers, this is the biggest division at about 630 species worldwide. A little bit of wow for you. They're exclusively wind pollinated. They often grow in these suboptimal places, mountaintops, poor soils. There's some exceptions like the redwood forests, but for the most part, this is where the conifers thrive, outside of the veil of the angiosperms. They're generally restricted to higher elevations and latitudes. You get north of the 45th parallel, and it's conifer heaven. And this is what I think is really wild. Less than 1% of all plant species, but they still cover 30% of the Earth's forested land. And that's mostly north of the 45th parallel. They also represent the largest, tallest, and oldest living things on Earth. In California, we got all 3. So if we look at this concentration of gymnosperms around the world, you'll notice a little pattern here. About half of all conifers are on the Pacific Rim. We zoom in on North America. 10% of the world's conifers live in the Pacific Slope, as I call it, California, Oregon, Washington, a little bit down into Baja, kind of including the California Floristic Province south. There's also a big hotspot here in the Sierra Madre of Mexico. This is pine heaven. We've got a good amount of pines, subtropical pines in this region. Pines really taper out as you move north. We have this meeting of the south and the north here. And then, why do we love the Klamath? Why do I love the Klamath? Because 5% of the world's conifer species live in the Klamath Mountains. So, across the Klamath Mountain region, this is what I define as the Klamath Mountain geomorphic province. Here's Redding, Mount Shasta. This is the Rogue Valley. And then as you get up into the Umpqua, that's the end of the Klamath to the north. The boundary kind of follows the North American and Pacific plate here at that edge. This is the long South Fork Mountain all the way down to the Yollobole, and then sort of across the foothills of the Northern Central Valley. So one of my, if not my favorite place on the planet, it has this central location within other mountain ranges. And this allows a mosaic of communities from the Cascades to the Coast Range to the Great Basin to the Central Valley. And this is what the Miracle Mile really captures, is conifers from all these different environments. We also have complex soils. This is just one example. The serpentine outcrops of West California and Southwest Oregon are the largest in North America. There's other examples though too, things like limestone. Outcrops promote diversity. And there's also this complex climate. So you'll notice that we are at the southern tip of the greatest temperate rainforest on the planet, but we also have these higher elevation peaks that capture rain due to the orographic effect. So we have this gradient of south to north, I should say north to south. We have a drying gradient from west to east, but we also have an elevational gradient of dry in the river valleys and wetter in the higher elevations. And this is a schematic that I have on my website, conifercountry.com, but it kind of shows how these conifers sort themselves out across the Klamath Mountains. And I don't want to spend a lot of time here, but this is kind of the area that the Miracle Mile is. So it's at this crossroads of the wet and the dry. It's got the high elevations, and it's got that influence from the Great Basin, from the Sierra Nevada and the Cascades. So we have this complex assemblage, an enriched assemblage, as John Sawyer would call it, of conifers. This is from my book, Conifer Country, and I know Eric Jules is on tonight. I want to thank him for torturing me into making this. But this is a list of all the conifers within the Klamath Mountain geomorphic province. But I want you to kind of focus on these little arrows on the right side here. 16 of the 32 conifers are either at the southern, northern, or western extent for their range, their range across the west. So we are, again, at this crossroads where all these species, some of them common, some uncommon, come together. We also have 3 of 32 endemics, and this has a lot to do with soils and also deep climatic changes. So the Baker cypress or Siskiyou cypress is endemic to the Serpentines, sneaks out into the Cascades a little bit. And then the Port Orford cedar and Brewer spruce once had wider ranges, and they become restricted due to climatic changes, and now they live only in the Klamath. And then 9 of 32 reach record size in the Klamath. And this is maybe not surprising in a lot of ways. I mean, obviously we have the biggest redwoods in the world up here, but things like incense cedar, which is a California floristic province specialist from southern Baja to central Oregon, gets really darn big right here. All right. So let's go into the Russian wilderness. And I'm going to tell you a story about sort of early explorations that helped define our knowledge all the way up to today about the Russians. Whoops. All right, here we go. So it starts with Ledyard Stebbins. And Stebbins was a botanist who's widely considered one of the leading evolutionary biologists of the 20th century. And I think what's it's sort of buried at the bottom of his Wikipedia page, but for any plant lover, he was instrumental in the establishment of the Inventory of Rare and Endangered Vascular Plants of California, created by the California Native Plant Society back in the 60s. So why does that matter? Well, it's still used by state and federal bodies for conservation and policymaking decisions. So Ledyard heard through the grapevine that in this place called Blake's Fork, along Russian Creek, within the Russian wilderness, that there were Engelmann spruce. So there was this new faculty member at Humboldt State named John Sawyer. He couldn't email him, he couldn't, I guess, even call him back then. Maybe he could have, but he decided the letter was the way to go. He wrote him a letter, and he said, get out there and document these things for our new inventory. And John was like, cool, I need, and John told me, so, let me back up a second. John and I took several hikes to the Russians, the Trinity Alps, and the Siskiyous, and I got to hear these stories, and I, vigorously took notes. So these are all based on things that I learned from John. John verified, yes, that's pretty much the way it goes. I think a few times we messed years up, But anyway, this is John's story. So I'm very fortunate to have heard these stories and to be able to share them with you. So John's an early faculty member. He's like, I'm getting out there. I need some research. So here's Russian Creek. And this is probably one of my favorite views in all the Klamath. Here's Russian Peak. Here's Russian Creek. And it comes up to this steep head wall. Obviously, this is a glaciated valley. And the Blake's Fork is just right down here on the other side of these arêtes. And I'm going to show you a Google Earth image of Blake's Fork. So I took that picture from up here, and Russian Creek flows this way. Here's Blake's Fork. So where Blake's Fork hits Russian Creek, and this is about 4 or 5 miles from any trailhead, somebody had reported Engelmann spruce. So John and Dale went on a journey, and this journey would change our understanding, in Northwest California at least, of conifer distributions, plant associations, and then also wilderness. I just got a notification that my internet's unstable, so I apologize if slides are lagging. This was my greatest fear tonight, that this would happen, but I'm doing my best here out in the boondocks. So here's Sawyer. I think this is Orleans Mountain. I think this is Salmon Mountain. So I think he's looking down the Salmon River here towards Soames Bar. But nobody really knows where this picture was taken. I think Eric Jules and I debated it at one point. But he's probably up somewhere maybe in the middle of the two forks of the Salmon. So John and Dale, after that first trip to Blake's Fork, they became enchanted with the Salmon Mountains. And the Salmon Mountains are a sub-range of the Klamath, sort of encompassing the Salmon River country. And they wanted to see more, and they went about planning and referencing it for the botanical databases. And they also found that Engelmann spruce had been documented along Sugar Creek, just over the crest from Blake's Fork. And I'm going to take you to Sugar Creek next and show you how that fits into this. So this is, you drive in from Etna, and there's a fork in the road. Here's Sugar Creek. And then here is the trailhead to get up to the Duck Lake Basin. So John and Dale, their first trip in 1969 was up Sugar Creek, and they had heard there were Engelmann spruce here. And the irony is, the Engelmann spruce are right on the road, but they just kept going. And as they got deeper, into Sugar Creek, they were documenting all sorts of plant diversity. And the current list is at about 400 species of plants. And I've put that list. J.P. Smith does a phenomenal job of updating these lists that they've been keeping for 40, 50 years now. And that is on my website, the newest version of that, thanks to the Humboldt Commons. But that'll be on my website that you can check it out. But what they did is they got up in here and they got to Sugar Lake, and they decided they were going to try to skirt up this slope here. And you can see just on the other side is Little Duck, and then on the other side here is Big Duck. And as I'm showing you this, the 18th conifer in the Miracle Mile showed up right here, and this is one that Dale and John never saw. So and I'll tell you about the 17 they found, but the 18th is right here, just for that reference point. So you up Sugar Creek, they bushwhacked up this south-facing manzanita covered. It looks okay with this rock, but the only way to get up there is to bushwhack through that montane chaparral. So nasty stuff. I've done it. I know all about it. And that chaparral must have cut them up. But they eventually found themselves, like I said, climbing this face on the way to Sugar Lake. From Sugar Lake on the way to the Duck Lake Basin. And here they are climbing up one of these steep slopes with their classic frame packs. I'm not quite sure this is actually what I'm referencing there, but it sure could be. And they reached the Duck Lake Basin. So to give you that perspective here, the other side of this ridge is Sugar Creek, and here's Big Duck and Little Duck. So they came up this ridge, and they dropped down, and they camped on this side of Sugar Lake. And then if you've been to I'm saying this wrong, Little Duck Lake. They dropped down to Little Duck Lake, and if you've been to Little Duck Lake, there's a little creek that runs in, and that's right about where they camped. And while they were there setting up camp, Dale properly identified the first subalpine fir in California. And then John always joked it took him a half an hour to convince him. He just didn't believe him. And I'm right there. Every time I find a new little pocket of subalpine fir, it takes me a long time to believe they're really subalpine. It's a difficult species to identify for sure. So around the campfire, they pulled out maps, and they had this idea. They were like, what if we drew this square mile around all this, what we just checked out? And they counted up the number of species of conifers. And lo and behold, they had 17. And the Miracle Mile was born. Now, since that time, I've had to finagle this square mile to encompass those western juniper that I was telling you about, Juniperus occidentalis, that I was telling you about. But here's Sugar Lake. They climbed up this face. They dropped in the Little Duck. They moseyed around Big Duck, got down low enough where they could pick up things like ponderosa pine and sugar pine. Could also get some of that down here. And this is a roughly drawn map of the Miracle Mile. And then that just spurred more research. So this is one of the original plot data sheets from the 1969 expedition into the Miracle Mile. And I'm going to give you a close-up. The Jules Lab scanned a bunch of these. And I just love these data sheets for a bunch of reasons. One is there's a bunch of scribbles, and you know, that's what we do when we're in the field. You make mistakes, you correct yourselves. It doesn't have to be this working piece of art. And this is, as an educator, this is what I'm constantly trying to share with kids. You know, like, it's okay to make mistakes. Just correct them, right? Work towards the correction of them. But look, they're looking at canopy cover. They collected all this data about seedlings and saplings. I'm going to show you the bottom of this. You know, they've got some rough estimates of where these places are. And then they collected shrub and herb data. So we know the species that were there, how many of those species were there. And this is what allowed the Jules Lab and Melissa and her team to get back out and replicate this. I'm going to tell you a little bit about that in a minute. But just fascinating to see some of these original data sheets from back in the day. And you know what's also fascinating is I do this vegetation research with CNPS. This hasn't changed much. We're still doing a lot of the same. It's organized maybe a little bit better. There's a little bit more data we collect. We look more at soils and a few other things. But heck, I mean, they were doing it the way it needed to be done. So good data. So here's a little picture of Sawyer on the left, Thornburg on the right, and their field assistant, Dan Frank, in the middle. And this is near the Miracle Mile in the Russian wilderness in '69. And I think this is at a car camp. And one thing I do know is they also knew where to find a good beer when they were done. If you've ever been to the Callahan Emporium, it hasn't changed a whole lot. And here they are hitting up Callahan. I just had to include that picture because it cracked me up. If you've ever been there, hopefully you're laughing too. So what did all this mean? Why is this important for Sawyer and Thornburg in the Russian wilderness? Well, their first, all that data, all that information they were collecting, it led to this roadless area review and evaluation process after the signing of the '64 Wilderness Act. Now, it took 20 years, but this ensured, this kind of held the ground there. It put a radar on this place as a future potential wilderness designation in this area. And then in 1984, the Russian wilderness was designated in large part to the efforts of these folks. John was consulted through the process by representatives from Northwest California, and ultimately he helped them okay this deal, basically. I mean, he wasn't super happy about it, but you know, there's always compromise, right? So there was a land swap, and there was negotiated this high elevation, less productive forest was swapped for lower elevation, more productive forest, probably full formerly of giant sugar pines. But what was saved with this swap? Well, the Forest Service was about ready to build a road and drive-in campground at Little Duck Lake. So thank the Lord, if the Lord exists, that didn't happen. And then we got the designation of the Sugar Creek Research Natural Area and the designation of the Duck Lake Botanical Area, both of which I have more information about on my website. This is just kind of a way to recognize, Todd Keeler-Wolf did a lot of the work here to initially assess and inventory these places. But these are basically hotspots of diversity that Todd and others identified across the whole state, went in the late 70s and early 80s, I believe, maybe it was mostly in the 80s, and inventoried, and now we know what's there. And these are biodiversity hotspots from plants to animals. So about 2009, John was leading a little hike in the area, and there was this guy in the crowd, and he said, you know what, I got your 18th conifer for you. And so John and I, we went to check it out. And this man purported it was the western juniper, and you can see the distribution. This is from one of my books here, the range of the junipers in California. But this is a Great Basin species. And it sneaks into the Scott Valley. It's common out here in the Great Basin, obviously Wairika, north of Mount Shasta, way out here in Modoc country. But it turns out there's a population in the Yollobole, and it turned out, though we didn't find it, we struck out because I hit this head wall. So I kind of did that bushwhack that John and Dale did, and I hit this head wall and I couldn't get over it. But I thought that the juniper were going to be on this granite, these granite outcrops, south-facing outcrops. Here's some common juniper. So I guess I wasn't totally wrong, but we failed that time. But a couple of years, maybe a year later, I was driving out to, of course, do some conifer reconnaissance. And I just pulled into the Moore's gravel pit. And Richard's, on his giant bucket loader, I only know the name of that because I have a 1-year-old who loves construction vehicles. But he was on his bucket loader. And I'm like, hey, Richard, can you tell me where the juniper is? And he's like, sure, I'll take you there. So he hops off this bucket loader, beats me to the trailhead, doesn't even bring a bottle of water or anything. And next thing I know, we're hanging off these granite cliffs looking at western juniper. So here's the gravel pit. This is his playground. He just goes up here whenever he wants and plays around, climbs all these places nobody else goes. So here's the juniper. Here's Richard showing it off. No water, nothing. Jumped on up there with me. And then this is not a new phenomenon. This is a mammoth juniper right here. Probably 800 years old. So birds, who knows what, Townsend solitaire, carried the seeds in, pooped them out many years ago, and lo and behold, there's our juniper. So we got our 18th conifer. And here's all the conifers in the Miracle Mile. And you can see it's mostly Pinaceae, but incense cedar, western and common. Here's our Cupressaceae. Got our firs, lots of pines, as you might expect. River spruce, hemlock, Douglas fir, Engelmann spruce, and Pacific yew. I'm still holding out hope for a knobcone pine one day, but that hasn't been found yet. So maybe we'll find a 19th. All right, so then that was our little discovery in the early, 2010s, 2011. Then this new crew came along, these young whippersnappers from Humboldt State. This is Drew Boast, Stephanie Brandt, Emily Stigter, and Melissa DeCervo. And they decided they were going to resurvey these vegetation plots that Sawyer and Thornburg had. So Eric Jules was able to sort of dig these out of the closet, so to speak, of John's house or somewhere. I forget exactly where they were. I probably should have asked you, Eric. But anyway, it would have made the story better. But dug these things out. They sorted them, organized them, geo-referenced them to the best of their ability. And then this crew got out there and did some work. So this was a super unique opportunity, as you might imagine, to research it back in Sugar Creek and continue this botanical legacy 45 years later. Sawyer died in 2012, Thornburg a year later. And this was a partnership that came about between HSU and the Forest Service with Ramona Butts, And it was a goal. The goal was to assess ecological change. So what's going on in 45 years? And they found some cool stuff. They particularly wanted to look at fire suppression and climate change on composition and structure of the forests. And they had a lot of friends that were interested too. This is a friend of mine, James Adam Taylor. He takes some really impressive photographs. He's been out with me on the Bigfoot Trail to photograph some of our trail work, but I wanted to celebrate some of his photos. I really like that one, this depth of field. So they looked at this change in forest composition and structure. They did 2 summers of data collection. They were hampered quite a bit by fires. The White's Fire in 2014 was a big deal, but they got it done. 155 plots. I don't believe they were able to find all of the plots, but that's pretty darn good when they had to make their best guess. There weren't GPS, John and Dale weren't just tapping their phone for GPX coordinates. They measured over 3,300 trees, and they recorded hundreds of understory plants. There's Melissa collecting some data on a Shasta fir. Another photo by James. So what did they find? Well, they detected important changes in forest composition and structure, including there was this increase in fire intolerant species. So as you might imagine, with fire suppression, there's certain conifers that are going to thrive if those fires aren't moving through, say, every 20 years. So if John and Dale surveyed, say, 40 years after the last fire, we're looking at 80 years before Melissa and her crew got back there. And these white firs had plenty of time to pioneer what should have burned. There's also this, and we see this across the Klamath, but I'm really excited that they found hard data on this, but there's extensive mortality in drought-sensitive higher elevation species, particularly the Shasta fir. 2 papers emerged from this. There's also a Fremontia article, and all 3 of the Fremontia and these 2 are linked on my website if you want to dive in more. I know this is kind of a general audience, and I didn't want to get into major details here, but they have some really nice conclusions and graphs, and it shows changes in a lot of the conifer species in the Miracle Mile. And then the last thing I'm going to tell you about here before we take a little quick tour of some of the conifers in the Miracle Mile is this Whitebark Pine mapping project. And this is something that Region 5 with Diana Cada started with Julie Evans and I at CNPS in 2013. And there's been a very sort of progression of funding over time. And in 2018, I was able to finally get in and do some mapping in the Russian wilderness. Here's Russian Peak again. This is Bingham Lake. What's fascinating about the Russians and whitebark pine is almost all of them grow on ridgelines, just like this. So here's the map of whitebark pine distribution. It goes a little higher into Canada, but you can see it's mostly concentrated in the Rockies. Blue Mountains have a few stands. These cool mountain ranges out here in Nevada. This is the Pine Forest Range. I went there a few years ago. Absolutely spectacular. One of America's newest wildernesses before our political system shifted. So this is now a wilderness area out there. And then the thick in the Sierra Nevada. But if we zoom in here in the Klamath, Northwest California, Southwest Oregon, you can see that the whitebark pine are thick on Mount Shasta and some other volcanoes north and east of there. This is the Scott Mountains, China Mountain Complex, Trinity Alps Complex. Here's the Russian Wilderness, Marble Mountains, and then this is Box Camp Mountain up near Lake Peak, which is the northern range extension for foxtail pine. So along this high elevation crest of the Klamath, we have these holdouts in the Sky Islands, one of which is the Russian Wilderness. So let's go into the Russians, check it out, what it looks like for whitebark pine. So this is one of the maps that we generated with the project. There's two different colors here that you will notice. There's a blue and there's a pink. The pink is whitebark pine dominant, so that's where the highest percentage of the species within those stands are whitebark pine. So you can see whitebark pine dominant is pretty darn rare in the Russian wilderness. It's more likely to be mixed in with mountain hemlock and Shasta fir. So there's, here's Bingham Lake again. There's a little bit of a stand here above South Sugar. Russian Peak has them, and then there's the spine above High Lake, and higher of the elevations out this way. There's some whitebark pine dominant. And then we were able to find a couple of really small stands out here by Siphon Lake above Russian Lake. So let's zoom in to this little stand above Bingham. That's where I took that previous picture. But here's the whitebark mixing in with this montane chaparral. And this sort of environment was maintained historically by fire. And pine mat manzanita, I think that's probably Cercocarpus or Great Basin, I'm totally blanking on the common name, Cercocarpus latifolius. Anyway, here's the whitebark stands. Curleaf mountain mahogany, sorry. And then lots of saplings. So the nutcrackers are going to town in the Russian wilderness. This is again a view down Russian Creek. But the nutcrackers are working these ridge lines. They're distributing these seeds and they're expanding the range along these spines within the Russian wilderness. This is a nice young sapling that I found at that head wall from earlier that I showed you above Russian Creek. So this area was impacted. Here's the Pacific Crest Trail running through here. This burgundy line here is the Bigfoot Trail. If you've never heard of the Bigfoot Trail, you should probably Google it. It's one of my favorite long distance hikes for a variety of reasons. But I'm going to show you a couple of pictures and you'll be able to pick out the Pacific Crest Trail through this, this stretch here. And so here's the Miracle Mile. And so we've got pretty rich, dense conifer forest. And then the south facing stuff is a lot of montane chaparral. And so in 2017, here's Russian Peak. That picture that I just showed you was taken from right here in the background. It's my buddy Ian. In 2007, you can see no fire scars. This area hadn't burned in a very long time. Lots of big whitebark pine. There's some top dieback. But that sort of desiccation happens in these windy areas. So here's from 2006. You'll see a lot of healthy forest up here. And then here's in 2015, after the Whites fire, you can see these patches of burn that moved through this montane chaparral. It moved up Russian Creek, mostly on these south-facing hillsides, and it almost got over the ridge to the Miracle Mile. There's a lot of concern. I remember some of my friends out in Salmon River country were emailing me saying, oh man, this might be the end of the Miracle Mile. But there's, you know, that geologic buffer there where the fire doesn't get over. And then on the other side, there's a lot of glaciated granite. So there's these spatially restricted microsites. So for whatever reason, the fire, well, for those reasons, the fire wasn't able to make it over the ridge. It burned mostly these south-facing hillsides. And you can see a year later, more of the fire scars become a little bit more evident. And look at all the montane chaparral just gone from out here. This is Russian Lake. This is a photo I try to take every time I go out there. I think I've mostly done that. And here's this is a photo from Melissa, but here's very close to where my buddy Ian and I were staying in 2007. You can see the fire actually moved into the whitebark pine stands. And this is one of the few photos in California of whitebark pine being impacted by fire. It just hasn't really happened yet, but I believe it will become much more common into the future due to climatic changes and aridification. So just a couple of thoughts about these charismatic high elevation species, the whitebark pine. Across most stands, we're looking at about 10% mortality, and that has to do, whoops, that has to do with, sorry about that, I messed that all up there. That has a lot to do with white pine blister rust and bark beetle. So the blister rust leads to a little bit of a decline in the species, and then the bark beetles move in, and they will often kill pockets of the high elevation whitebark pines. And sort of a novel ecosystem for them. They're able to move higher up slope due to the warming and the extended growing seasons or reproductive seasons. Like I said, most by mountain pine, some by white pine blister rust. But overall, large trees do appear to be in slow decline, but the seed, so far, seed production and reproduction are appear healthy and vibrant. Okay, so other conifers of the Miracle Mile. This is just a couple, about 5 more minutes, maybe less. I'm going to show you sort of how these trees fit within the spectrum of the Miracle Mile. And then Renee and I will take a few questions. So here's again, let me orient you here. Here's the trailhead for Duck Creek. So when you hit this, you kind of weave up these old logging roads. Oh, actually, sorry, you go this way. This is Music Creek. You wind up these old logging roads. It's a little torturous and hot when you first start out. And then you traverse across this old logging road, and this is where you hit Duck Creek and you can get up to Duck Lake. So keeping that all in mind, this sort of lower elevation area here, you can see it was extensively logged due to those logging roads, because this is Ponderosa and Sugar Pine Heaven. They left a couple of the pockets of these things, probably where they couldn't get to them because of the steepness of the slopes. But most of that old growth, Ponderosa and Sugar Pine, was logged out. Now, if we go a little bit higher, so once we hit this is sort of the terminal moraine here of one of the major Pleistocene glacier events. There's another moraine up here. But at the end of this moraine is where you get into the Engelmann spruce. Here's our graphic of the distribution of Engelmann spruce, common through the Cascades and the Rockies. And then just a few pockets here in California. This is out in Shasta County, and then the heart of the Russians, and then that's really about it for Engelmann in California. That's it that we know of. Here's my buddy Jeff Kane. This is actually in Blake's Fork. This is just a beautiful stand, old growth Ponderosa, Douglas fir, sugar pine, and then the Engelmann spruce mixed in. I just really love this spot. And it was able to, that White's fire sort of moved around and somewhat through it. And the trees are still looking really healthy. At least they were 2 years ago when I was there. And then one thing that we did in the Miracle Mile, my friend Matt Ritter runs the California Big Tree Registry, and we didn't have a record Engelmann spruce. So this was a group that I led a day hike into the Miracle Mile. And we saw 17 of the 18 conifers this day. We didn't get to the juniper, but we also nominated the California champion Engelmann spruce. Brewer spruce, one of my favorite conifers. Just going to end with a couple of my favorites here. Here's the cones. You can see the bracts are a lot less papery than we see in, they're firmer as well than we see in Engelmann and Sitka spruce. They have these long pendulous branches, and the spruce-like bark with these circular platelets that flake off. And then lastly, so here's Big Duck, Little Duck. Not lastly, actually there's a couple more. In these lake basin areas is where you find subalpine fir. As I mentioned earlier, this is where Dale first saw them at Little Duck Lake at the outlet. And this is the same story as the Engelmann spruce. We're at its southern range extension in Northwest California. Engelmann spruce and subalpine fir are synonymous in the Rockies and the Cascades. If you see one, you're going to see the other. In that case, is true here in the Klamath for the most part. There's a couple pockets of subalpine fir you don't see Engelmann spruce, but it's believed that these are kind of a more recent arrival at the end of the Pleistocene. For whatever reason, those big glaciers pushed south, and these moved up into the higher elevations and are now pioneering, the subalpine fir are now pioneering some of the meadows just over probably the last 10,000 years. They're not extensive stands. And then here's the stand that Dale and John saw. This is at the sort of the south end of Little Duck Lake, and you can see this pirouetted crown. This is very distinct. It's a dark crown, and it comes to a distinct point. Unlike some of these lodgepole pines or the other white firs in this area, Shasta firs in this area, they have more of a Christmas, more gradiated crown. All right, and lastly, this high elevation pocket right above the lakes is where you find very, very few foxtail pines. There's probably 30 to 50 individual foxtails in the Miracle Mile, if that. So this is my personal favorite conifer. It's related to the bristlecones. The bristlecones can be found in the White Mountains and then out across the Great Basin. There's the Rocky Mountain bristlecone. There's the southern foxtail pine, Balfouriana subspecies australia, and then the northern foxtail pine, or Klamath Mountain foxtail. And these are the sky islands across the Klamath, down into the 2 pockets in the Yoloboli Middle Eel Wilderness. And here's what they look like in the high elevations of the Russian wilderness. Okay, so all that being said, I see there's some questions streaming in. Hopefully it's not that my internet's been breaking up all night, but if it was, so be it. But I want to thank John. John was a huge influence on my life towards the end of his life. He took me under his wing, turned me into a conehead officially, and indoctrinated me into the world of higher education by convincing me to turn my book, Conifer Country, into a master's degree at Humboldt State. And it was the first project-based master's in 25 years. And John was on my committee. It was the last committee, I think. Maybe he might have been on one other committee, but one of the last committees he was on before he passed. And it made the book so much better to have him both advising me and editing me. But a couple of things to consider about this Miracle Mile. I got a little bit of grief on social media for like exploiting the Miracle Mile. Not everybody's going to go there. But I think it's important to share beyond some cool lake or some cool view. We got to know more about a place to develop a love and a passion for it. And that's why I originally included this hike in my book, Conifer Country. Most of my hikes in there aren't in wilderness. They're in just areas that you can almost drive to, right? This is a special spot. It's in wilderness, but we can all be better stewards because of the amazing research that's been done here, biodiversity that's here, and the natural beauty. So that all being said, I just want to remind you, this has only been a wilderness since '84, and it's now designated as 2 research natural areas, both the Duck Lake and Sugar Creek. And when you go there, please tread lightly, leave no trace. Tell your friends this. Teach them about the conifers, go on a scavenger hunt, but consider doing it as a day hike, passing through on a longer trip into the wilderness. I've never camped at those lakes. I've camped back there 10 times, and I guarantee you I've had a better camping spot every time than the lake shore, at least in my opinion. Often on mountaintops. So there's plenty of places to spread out back there and lessen your impact. So just keep all that in mind. That's my soapbox moment, also to defend myself a little bit better against some social media some outlash that I got. Okay, this is my wife Allison. This is us in 2006, and our first trip here's Russian Peak, our first trip together into the Miracle Mile. And I want to thank her too for all her support and her love of all things wild and letting me kind of get feral every once in a while and run around the woods. I gotta plug it. I'm sorry, I'm plugging my book. This is due in 2021. If you love the Miracle Mile, you're gonna love this even more. This tells the most comprehensive story that's ever been told about the Klamath Mountains. And we are diving in deep. We're looking at snails, amazing diversity of snails. You think conifers are cool? Well, conifers are pretty cool. But the darn snails of the Klamath will blow your mind. Not only that, we've had 3 new species of salamander described just in the past year, and a new one was found in the Castle Crags last year, and nobody knows what it is. So we got this amphibian story. We got the plant communities, me and Julie Evans and Julie Kierstead and Michael Murray. So I could go on and on, but it's an all-star lineup. Go to Backcountry Press, sign up for my email list, join us on Instagram. My wife, I have a note right here. Follow Backcountry Press on Instagram, please. My wife just loves it. She does a good job too. She tells good stories, and it's valuable content. So anyway, I'm going to stop glowing about this new book. Hopefully 2021 happens. COVID's really set us back a little bit, but I think we're going to make it happen. And that's it. So I want to thank you. When you do log out, you'll be directed to a survey. I'd really appreciate your feedback. If I said something wrong, if you have a question, you got to go. You don't want to hang around for this. You can type it all in there. You can also opt into the email list for Siskiyou Land Trust and for Backcountry Press. All right, I'm going to stop sharing, and Renee's going to come on and we'll do a few questions. Thank you all for your time.
All right, thank you, Michael. That was delightful, and we do have a lot of questions. So I want to let people know we'll work our way through those, and stick with us for as long as you would like. I'm kind of going to start at the beginning and work my way down. So Michael, first question from Lisa Hintz. I've never heard of an extant non-woody herbaceous conifer or an annual conifer. Are there any? Have there ever been any found in the fossil record? And if not, why might this be?
Jeez, that's a tough one. You know, as much as I love conifers, or in gymnosperms in general, I have to admit I'm basically a West Coast, I should say North America. I know my North American conifers. That all being said, the weirdest conifers are in New Caledonia, in the basically off the coast of Australia. And there is a parasitic conifer there, and I don't know if it's an annual or not, but it's a weird one. I don't think there's any annual conifers, but I can't say it definitively.
All right. Okay, well, moving on. Bill Hefferman asked early on if you're aware what the impact of cattle grazing on conifers has been in the Russians or the marbles.
You know, thankfully, most of the Russian wilderness is small. Most of it's been excluded. There's a lot of cattle grazing that comes out of the Scott Valley, and I get it. It's an old tradition. You know, they're not killing it. I shouldn't say kill. I mean, by killing it, I mean the landscape. They're not killing it necessarily in the Russians as much as the marbles. The marbles are getting hammered. Probably shouldn't say too much here, but I'm not pleased with this kind of approach to cattle grazing. We don't need to be running cattle into pristine conifer forests. Yeah, they trample them. They trample the roots. They affect the meadows. I guess maybe one saving grace could be due to lack of fire suppression. Meadows are getting encroached by conifers, and maybe the cows are trampling those out of there. But man, some of those canyons in the up Shackleford, from Shackleford Trailhead in the marbles, it's a little rough. But mostly in the Russians is okay, and I think there can, a few cows, sure, let's do it, but we don't need to be running herds up there. That's my soapbox.
Okay. All right. Moving on to another question from Joseph Valle. What do you think climate change might do to some of these disjunct conifer populations and their distribution in the Klamath?
Yeah, great question. That's the $1 million question, or maybe it's a $1 billion question now. But so my last presentation you can find on the CNPS North Coast website under education and evening presentations. I focused on basically the rarest two conifers in the Klamath, which are Pacific silver fir and yellow cedar. And they kind of tell opposite stories in a lot of ways. The yellow cedar for now are doing really well, and a lot of these high elevation relictual conifers are doing well now, and the irony is they're doing well because it's getting warmer and the snowpack is decreasing, and they're able to now reproduce and spread into these gaps that formerly were covered by snow deep into the season. So that's a short-term success. Now, will it be a long-term success? I kind of doubt it. So I wonder in 50 or 100 years when people go back and visit these plots that we're doing, they're going to find something a lot different because with aridification and warming, I think these plants are going to start to struggle. So I really worry, particularly pines right now. The pines, western white pine, whitebark pine, and foxtail pine are all in decline due to climate change. And pines are in decline for a variety of reasons. And I won't get into the details, but they're kind of that harbinger for the high elevation decline due to climatic change.
All right, thanks. And now I've got a three-part question for you from Bill Winterburn. He asks, how much water does a tree use? Can you graft any conifers? And when a forest is harvested, is it replanted with the same tree or hybrids?
Okay, so I'll work backwards. Hopefully there's good practices for replanting where the genetics are coming from close by, but you know, it just depends on the company and who owns the land and where that's coming from. The second one was about grafting. I don't do a lot of that. I'm a wild conifer guy. I'm not a cultivator. So I would imagine you could, but I'm not the one to ask. And what was the first one again? Sorry.
How much water does a tree use?
Well, it depends on the tree species for sure. Redwoods, Steve Stillett was just on. He could, I mean, it's thousands of gallons for a redwood tree, but it just depends on the physiology of the species. Pines don't use as much. You know, there's a lot of these species will shut down in the dry season and they won't photosynthesize for 6 months. So it just depends on that species.
All right, thank you. And I'm just going to keep going, folks. We still have a lot of folks hanging out with us, so I'll keep working through the questions. Next one for you, Michael, is from Dave Brennan, and he asks, on the map earlier of juniper distribution, did it show that Sierra junipers are a separate species?
Yeah. So Robert Adams did some work, and my juniper searching actually, that was the first scientific paper I ever published was with Adams. He said, get out there and figure out what we got in the Illaboli. And so he split those two species, Juniperus occidentalis and Juniperus grandis, into two. And basically grandis is high elevation Sierra. And then in the transverse ranges, there's like 20 individual specimens in the San Gabriels, and then they're a lot more common in the San Bernardinos, the eastern San Bernardinos, where they get a lot of those monsoon summer rains. But and then north of the Sierra in the lower elevation, Great Basin, that's Juniperus occidentalis.
All right, thank you. And then Mandy Twitchell says, I loved being part of the Whitebark Pine surveys for the KNF. Were the surveys in 2013 that you mentioned connected to all Whitebark Pine surveys in Northern California?
Yeah, so if you Google Whitebark Pine in California, it'll probably bring you to my website. And we have all the papers by forest posted. For some reason, they're not on the CNPS site, but anyway, they're on my website. And we have just finished an extensive report that sort of assimilates all that data and information. We have layers now across all forests. We've worked with Michelle Slayton, who's worked extensively in the Southern Sierra. And then, I mean, to be honest with you, I did most of the mapping north of Lassen. We didn't really know where Whitebark Pine were. Might possibly be the best job I've ever had. I just got to pick high mountains and climb them. And now we have a map of where all Whitebark Pine are in Northwest California, well, Northern California. So yeah, that's all on that website. You can see forest by forest reports. And then we have new maps based on what we've integrated with work with different scientists across the state.
All right. All right, and then I've got a question from Darren Stringer. And just to give you some context, Darren is the lead forester for EcoTrust Forest Management, who's the partner that we're working with on those conservation easements right below the wilderness area. And he asks, what is your wish list of other conifers yet to be discovered in the Miracle Mile?
Well, like I mentioned, knobcone pine, and I really don't think there could be much other than that. But one thing I didn't mention is that there are a lot of these enriched conifer forests across the Klamath that we're continuing to find. So for instance, the Devil's Punch Bowl in the Siskiyou Wilderness has a whole different assemblage of conifers, but there's only 16 species only. There's some little spots in, even in Canyon Creek, a place that everybody goes, right? If you go to the Klamath, you go to our little Yosemite Valley, there's one spot where you kind of hit the trail junction with L Lake and, or not L Lake, the first trail junction of the lakes there anyway, sorry. You pull a circle, you'd stand still, you can see 10 species within 50 feet of you. So we have all these cool pockets, and that's where I think the discovery is, right? Keep learn your conifers, learn your plants for that matter, and get out there and find some cool ones, find some neat assemblages. And let's designate some new research natural areas like Todd Keeler-Wolf did in the 80s.
All right, and since you just brought up the research areas, someone asked here what the difference is between that designation and a wilderness designation.
Yeah, so the research natural area doesn't mean a whole lot, unfortunately. It basically means that this place is pretty botanically just biodiverse, I should say. So my understanding, and I wish Todd was on. I should have invited Todd Keeler-Wolf to join. He would have been great to ask to talk about this real quick. But basically, research natural area. He did the same thing I did with whitebark pine. He assimilated information. He heard about these biodiversity hotspots, and he went out and he documented these things. So one of my favorites is in Conifer Country. It's not in wilderness. It's in the headwaters of the Sacramento River, just out of Mount Shasta. It's Cedar Basin, research natural area. And Cedar Lake, so right there, there's a couple private inholdings around those lakes, but you're totally, it's basically Klamath National Forest. And you can walk right up in there. You can see Port Orford cedar in the west and the eastern Klamath, which is, weird because Port Orford cedar is really a coastal species these days. You can see Drosera rotundifolia, which is a carnivorous plant. You can see Darlingtonia up there. So this is these are just cool places that ecologists like Todd help document. Wilderness is a formal federal recognition that is now roadless. So there's no mechanization, no mechanized vehicles. And the 1964 Wilderness Act, in my opinion, was probably the most important, maybe outside of national park designation, was probably the most important. My wife's filming me speaking to everybody, but probably the most important act that the U.S. government passed, because I love wilderness, and it just means you can't do anything to it. You leave it alone. And that's what we need more of. We need this for the health of our planet, and the United States is doing a good job preserving that stuff right now.
All right, thanks. And then the next question on my screen from Lyra Cressy. She asked, why do you think the Port Orford cedar's known distribution skips the Salmon Mountains, but is present to the west and to the east? Or have we just missed finding them in the salmons?
Hey, Lyra, thanks for joining in. Yeah, good question. So there's two phenomenon with the storms in the winter. The first phenomenon is the storms come from the northwest, and they kind of hit the Klamath. And those big storms, that's why Del Norte County gets 100 inches of rain. It's a rainforest. Humboldt County is a little drier. These storms kind of come in from the northwest, and that through that orographic effect, those storms dry out as they move across the Klamath. There's another phenomenon where storms move up the Central Valley and they stall out orographically over Shasta and the Scott Mountains, Mount Eddy, China Mountain, and that's the headwaters of the Sacramento River. And so that's the philosophy or the idea about hypothesis as to why the Port Orfords are still there, because of those type of storm.
All right, thanks. And then got an essay question for you from Mandy Twitchell. She asked, do you have an opinion on the white fir of the area here, Mount Shasta especially, as far as taking them out, as in removing, in the typical Pondo Doug fir forest? I have a ton of my property that seem to just be a problem, dead or dying, beetles, etc. I believe fire suppression has helped them take over, so to speak, and I feel like I would like to take them out so that my sugar pines, Doug fir, incense cedar, and canyon live oak can thrive. But is that overkill? I understand this would be your opinion. What do you think?
Sounds like you need to contact the HSU Forestry Club, and they'll come over there and harvest your trees and sell them next Christmas. Yeah, my opinion is young white firs, they act as ladder fuel, and they can carry fire in the future, potentially up into the canopy of older trees. I love white fir, but I'm not a fan of that high level of encroachment, and I do think it's wise to watch how dense they get, because they could blow up in a fire if that happened.
All right, and then I see a question from a buddy of mine, Shawnee, asking about something close to her heart. Has there been much research on mycorrhizal networks in some of these conifer biodiversity hotspots, and how might they be contributing to the health and maintenance of these unique mixed conifer stands? Or has there been other interactive ecological research to better understand why this area is so special for biodiversity of all kinds?
Yeah, that's a really good question. And I'll be the first one to tell you the roots of any tree are the least studied part of the whole environment, right? We don't really know. And I'll just make one, I don't know a lot about this at all, and I don't think there's been a lot of research in the Klamath, but what we do know is that supposedly the largest organism on the planet is the Armillaria colony in Oregon, right? And across the, I think it's the Blue Mountains or John Day or something, some one of those mountain ranges out there, Aldrich Mountains. Anyway, mountains out there are a lot more contiguous, right? There's not a lot of relief, high elevation, steep slopes. There hasn't been glaciation in the high peaks. So species like that can spread out over longer distances. In the Klamath, we've got a lot of these isolated, smaller population size areas that you know, I don't think this is one of the fears of the Klamath, right? We have basically genetic isolation in a lot of cases because of the topography. There's not a continuous homogeneous landscape. So if we do have extensive mycorrhizal fungi, the extensive word is going to be a lot more restricted based on the topography and being able to move between species. I'll leave it at that.
All right. And then this question, the foxtail pine intrigues me. The distance between Southern Sierras and Klamath Mountains, is that species so ancient that plate tectonics play a part in that distance? Did the Klamath population ride up to Northern California?
Yeah, that's the general idea, is that as the plates spread, they've been separated for about 1 million, maybe more years. And then, you know, with climate change, these things are moving around, right? Throughout the Pleistocene, there's pollen records of them in Clear Lake. If you ever driven Highway 20, there's foxtail pines used to be down there. So they're moving, right, in all these ways. And then all of a sudden the climate changes in the Holocene, and they move up into these high elevation pockets. So there's a little bit of tectonics and there's a little bit of climate change. And this is my anthropomorphized finger version of them dancing the landscape.
All right. So we still have a lot of folks with us, and we still have questions piling up. So I'm going to keep going through questions. The next one from Jerry.
I got a little baby that's got to go to bed, so maybe we can do about 5 more minutes.
All right,
yeah.
Sounds good. All right, so from Jerry Jordan, regarding the mistletoe that is becoming, whoa, questions just jumped. Hold on, a bunch more just came in. Here we go, Jerry Jordan. Regarding the mistletoe that is becoming more prevalent in red fir, is it being exacerbated by climate change?
So this is an interesting, I really like that question. And I think there's a couple things going on. I've got this hypothesis that there was a little ice age about 150 years ago, right? And since the end of that ice age, trees have put on growth. They put on more branches. They've moved into these pockets that are there's less snow. And I think now they're sort of responding to that rapid growth. And the mistletoes are able to spread more because the branches are denser. Things are drying. So fir and graver beetles are moving in. So I think we're seeing this rebound from about 100 years of rapid growth after the little ice age. And we're seeing a decline, and it's very noticeable. I don't think I included a canopy picture, but Melissa DeSerra's team got some good ones. I've got other good ones, but you know, you see this branch dieback. And I think that phenomenon has to do with the drying, also the mistletoe, and also the fir and graver beetle. So it's a combination of all sorts of stuff, you know, current climate change and past climate changes.
Okay, we'll do 2 more questions. From Ernie Wasson, what effect does forest fire smoke have on conifers?
Smoke?
Yep.
Yeah, I mean, it can, it depends on the that's a good question. We got a cool graphic in the book coming up by Bob Van Pelt, who's one of my favorite tree artists. He lives up in Seattle. He does work with Steve Sillett here in the Redwoods. But Bob made this cool graphic about all the effects that varied levels of fire, smoke, what that can do to a forest. And the bottom line is if it's dense enough, it's going to kill. You know, it's going to suffocate needles. It could be hot and burn the needles. So there's a whole variety of influences that fire can have. Smoke can definitely be detrimental.
All right. And let me see. From Henry Holbrook, you touched briefly on the canopy cover study by the 1969 botanist. Could you explain that a little more?
Sure. Henry, if you ever want to go out, take me to some of your secret spots. I think this is the same Henry up in Del Norte. Just let me know and I can show you this. But basically what you're looking at, you know, Julie Evans taught me all this, and I don't know if Julie's still on. Hopefully not, because I'm probably going to butcher something here. But Julie basically said, look, Julie's the vegetation ecologist. She wrote the Vegetation Manual of California. She helped define, refine these rapid assessment protocols that Sawyer and his crew sort of invented. And this is what we run across the state for CNPS. But basically, if you're in the densest, dankest redwood forest on Earth, you're looking at maybe 60% max canopy cover. So you're kind of back away from that. Some people use these optical lenses that's sort of the fisheye, and you can kind of see the amount of cover within, say, these little square centimeters within that, and that helps you estimate it. But that's all you're looking at. You're looking at how much above you is sort of covered by the canopy of what species. So generally in the Russian wilderness and these whitebark pine stands, we're looking at max like 10% canopy cover. And it's typically like in a whitebark pine dominant, you're looking at like 6%, 5% whitebark pine, 3% mountain hemlock, you know, so it's, and those just add up. And that gives you your percent canopy cover. Then you can also get ground cover and, you know, different other measurements for shrubs and herbs and everything. So that's how they do it. And then you add that all up and it tells you, you know, vegetation cover.
All right. Well, like I said, Michael, there are more questions coming in, but I do want to honor your evening. So thank you so much for the presentation. And, you know, like Michael said, folks, getting out there and seeing these places are ways to be inspired to protect them. So I want to encourage you to go out and see the forest, whether it's the one nearby you or if you come out and visit the Miracle Mile. It certainly is important to be inspired. So thank you for being here tonight. Thank you for supporting Siskiyou Land Trust and the North Coast chapter of the California Native Plant Society. Thank you for your enthusiasm for Michael. And with that, we will say goodnight for the evening.
All right, good night, everybody. Thanks, Renee. I appreciate it.
Yeah, thank you.